welcome to our lesson this afternoon. We're going to be having some fun, and this afternoon we're going to continue with our topic computation, and we're looking at square and square roots of different numbers. Now we're going to take the square of numbers first. Now when we were looking at number bases, if you can recall, we talked about 10 and powers of 10. And you can remember we had the number 10 and we squared it. And when we squared the number 10, what did we do? Miracle?
We multiplied 10 by itself.
We multiplied 10 by itself, or we can say we multiplied 10 by 10. So the square of a number is the number times itself. Now let us explore and find the square of these numbers that are listed. So we're saying the square of a number is the number times itself. Good. Now we are going to find the square of these numbers that are listed. So we'll start with 1. So here's how we write 1 squared. And we say the square of a number is the number times itself. And when 1 is multiplied by 1, the product is 1. Now we move to 2. The square of 2 would be 2 multiplied by 2, and 2 2's will give us a product of 4. Very good. Now that was the first and the second number. I will skip the third and the fourth, and I'll move on to the fifth. So we have 9 raised to the second power, and we call that 9 squared. And it would be 9 multiplied by 9, and we would have a product. So what you will do for me, you will write the square 4 and 5 as square numbers and find the square of 4 and 5, and then you will give me my answer for 9 squared quickly. We'll start with Neon. Neon, what did you do for 4?
4 squared
4 raised to the second power
equals 4 times 4,
4 multiplied by 4,
which is equal to 16.
Very good, Neon. Miracle, what did you do with the 5?
5 raised to the second power
5 raised to the second power
is equal to 5 multiplied by 5.
Very good, and the product would be
25.
25. Jonathan, what did you get when you multiply 9 by 9?
9 squared.
9 squared, and the product is
81.
81. Very good. Now here we have been squaring whole numbers that are positive. The next two numbers are two negative numbers, -3 and -6. And we want to square those also. So -3, let's put that in a pair of parentheses, and we square it. And we have a -3 is being multiplied by a -3. And when a negative is multiplied by a negative, our product would be positive. So 3 3's would give us a positive 9. Please square for me -6. Good. So we looked at positive whole numbers, and here we have two negative wholes. We want to find the square of those numbers also. So -3, we put -3 in a pair of parentheses, and we raise it to the second power. And that tells us that it's -3 multiplied by -3, and our product is a positive 9. Because when a negative is multiplied by a negative, our answer is a positive. Good. Now I want you to find the square of -6. Keisha? What did you do with the -6?
Put -6 squared in brackets.
Negative 6. You put it in a pair of brackets. And you put a little 2 up there.
Which is equal to
Yeah.
negative 6 times negative 6.
Yes.
Which is equal to 36.
36. Very good, Keisha. So we have whole numbers, positives, and negatives. And what we notice is that when we square them, whether they're positive or negative, our products are all positive whole numbers. Now let us try some decimals. 0.2. We want to square 0.2. And then we have 0.2 multiplied by 0.2. And our answer is 0.04. Now 0.04, if you can remember, is a 2 dp number. So 1 dp and 1 dp, we have a 1 dp in the number we're multiplying first, and by 1 dp in the number we're multiplying second. So 1 dp plus 1 dp would give us 2 dp in our answer. Okay? Good. So that's 0.2. Now the second number is 0.01. It's your turn to find the square of that. Yes, Miracle. From the number, what's the second step? What did you put here?
0.01
0.01
raised to the second power.
raised to the second power. Now let's pause a bit here. In 0.01, how many dp's are here? 2 dp's. Let's continue. Next step.
0.01
Yes.
multiplied by 0.01.
Now, before we ask for our product, we have 2 dp's, 2 dp's. Neon, how many decimal places would be in our answer?
4 decimal places.
4 decimal places. Miracle, what was your answer?
0.0001.
So we have 1, 2, 3, 4 dp's in our answer. Very good, Miracle. Now the last one we have here is 2.3. We have a mixed number here. Quickly compute the square of that mixed number. Okay. So we know that if we're going to square 2.3, it will be written like that. Then we'd have 2.3 multiplied by 2.3. And Renee, what did you get for your product? 5.29. So here we can see if we take a number and we multiply the number by itself, out comes the square of the number. Okay? Good. Now we're going to try some fractions. We have a third, and we want to square a third. So it's the same process. 1/3, and we're going to square, and it's the number times itself. And remember, when we're multiplying fractions, we go numerator by numerator, denominator by denominator. What do you think our outcome or our product will be, Neon?
1/9.
1/9. I want you to practice on 2/5. So I know that you took 2/5 and you squared it, and then you multiplied 2/5 by 2/5. And Jonathan, what did you get?
4.25.
You got 4 over 25. Now let us check back to see if that's correct. Good. Now Jonathan, you said that when you square 2/5, you got 4 over 25. Now let's go and write 2/5 as 2/5 by itself to make sure we get that. So at this stage, we should be writing 2/5 multiplied by 2/5. So we have our multiplicand and our multiplier. 2 2s are 4, 5 5s are 25. Okay? Now here we have a negative 3/7. And I would like you to square it and find the product. Now before you get into that, what must you remember when you see the minus sign?
Negative by a negative equal positive.
The negative by a negative, our product must be a positive. Quickly. Neon, when you found the square of negative 3/7, what was your product?
Positive 9
Positive 9
upon 49.
over 49. So we know 3 3s would be 9, and 7 7s would be 49. And a negative by a negative would give us a positive. Good. Now here we have some smaller numbers, and we also want to square them. And to square these, we're going to make use of our table of squares. Now let us just imagine a calculator is not around, and we are in a hurry. Time is against us, and we want to quickly square these numbers and finish our business and go our way. We make use of something called a table of squares. Now every one of you have a copy in front of you. Now how do we go about finding the square of a number using the table of squares? Now our first number here is 1.03. Now in the first column on this page here, you see 1.0, 1.1 until we get to 3.9. Now 1.03 is a 2DP number. So when we go to the table and we see 1.0, that's 1DP. We move across in the first column and we stop at 3. We move across in the first row, 1.0 all the way to 3. We stop at 3. So that would give us the number 1.03. What is the answer there when we stop at that column there, where 3 is? 1.06. So first we look at the column. At the first column, we have 1.0. Now, when we look across, we see 0, 1, 2, 3. Now, our number, we need 2 DPs. We have 1 here already. So here, this would give us 1.00, 1.01, 1.02, 1.03. So where this row and this column intersects, here we'd have 1.06. So the square of 1.03 would be 1.06. Now I want you to use your table and find the square of 1.27. 1.2. And then you move across and you find the 7th column. And you see where the row 1.2 and the column 1.7 intersect. And you circle your answer there. What did you get, Miracle?
1.61.
1.61. Did you get that, Keisha?
Yes.
Did you get that, Jonathan?
Yes, miss.
Good. Our third number, 1.382. Now, our table only has up to 2 decimal places. So we're going to approximate this number to 2 DPs, or 3 significant figures. So this here would be approximately equal to 1.38. And then we're going to square this. So find the square of 1.38. Neon, what you found? What is the answer?
1.90.
1.90. Now, our fourth number is 53.2, and we want to square that. Now, when we look through our table of squares, which would be the first 2 pages, we see that the table stops at 10. So it means that if we turn through, we would not find 53.2 there. Now let us make use of our previous knowledge. We know that we can rewrite 53.2 in standard form as 5.32, and we multiply by 10 because we have moved the decimal point 1 place from here to here. Okay? So we took 53.2 and we rewrote it. And we wrote it in standard form, and this is what it is. Now, if we go to our table, we can find 5.32. But before that, 53 in standard form is this. Okay? Good. Now remember, we want 53.2 square. So if we square 53.2, we're going to have to come over here and find the square of 5.32 and also the square of 10. Now I want you to go to your table and find 5.32 squared. Good. When we square 5.32, what did we get?
28.3.
28.3. Now remember, 10 squared would be 100. When 28.3 is multiplied by 100, remember we say when we're multiplying by 10 and powers of 10, we simply move the point. That the number of zeros indicate to us how many places we should move. So we go 1, 2. Fill in that holder there. So we have 2,830. Any questions? So you see how we can use scientific notation or standard form along with our table of squares to find the square of a number that isn't on our table. Now let us continue. We want to find the square of 207.3. That's your challenge. Go ahead. First, you're going to take 207.3 and you're going to write it in standard form. Let us go in steps. Write it in standard form. And when you wrote 207.3 in standard form, what did you get, Jonathan?
2.073 multiplied by 100.
Multiplied by 100, which is the same as 10 squared. Because this 2 told us that we moved 2 places. Okay? Good. Now we have the number 2.073, which we can find But then we have to remember that on that sheet, you only have 2 DPs, up to 2 DPs. So we're going to approximate 2.03 to 3 significant figures, which would be 2.07, and then we're going to multiply by our 100. So find, now we apply our square. We want 207.3 square. So we're going to have to square, and then we squared here. We have to square here also. Good? So we have an answer here, and here we would have 10,000. Did you find it, Miracle? Did you find the square of 2.07 on your sheet? 2.07. What did you get ready?
4.28.
4.28. And when we multiply 4.28 by 10,000, our product is? How many places do we have to move the point?
4 places.
4 places. So we go 4, 1, 2, 3, 4. So the product of 207.3 would be 42,800. Any questions? You enjoying it as we go?
Yes, please.
Good. So we looked at how we can square numbers. And we squared whole numbers, whether they're negative or positive. We looked at decimals, we looked at fractional, and we also looked at the mixed ones. Okay? Now, if we're not squaring on one side, we're finding the square root on the other side. And the square root of a number is basically the inverse of what you're doing to square a number. So, we have a number 4. And when you have a number 4 and you're thinking square root, you're asking yourself, which number did I take? Multiply it by itself, and I got 4. Which number was that?
2.
The number is 2. So the square root of 4 is 2. And the symbol we use to write square root is, and we put the 4 beneath it, and there we'd have our answer. What number did we take, multiply it by itself, and the outcome is 49? 7. So here we write the square root of 49 is equal to 7. So you're going to finish up 0, 9, 25, and 36. Give me their square roots. Yes, Neon, what's the square root of 0?
0.
Keisha, what's the square root of 9?
3.
3. Miracle, what's the square root of 25?
5.
Jonathan, what's the square root of 36?
6.
6. Now, if you notice here, the square root of these numbers are all positive. We took the positive. Now, the square root of any number is both the positive of it as well as the negative. But in these first cases, we only took the positive. But anytime you're finding the square root of a number, you will have the positive as well as the negative. Now, why is that so? Now, our number is 4. How can we possibly get 4 when using 2 and negative 2? So let's try it here. A negative 2 multiplied by a negative 2 would give us a a positive 4. And a 2 multiplied by a 2 will also give us a positive 4. So if we find the square root of 4, our answer should be both a positive and negative. Now there are times when the negative is not needed, it depends on the situation, so you don't use it. But you must know that the square root of a number is both positive and negative of it. So we would normally write this as plus or minus 2. Now let's proceed. We're trying decimals now. We have 0.04, and we want the square root of 0.04. Now, if you can remember, when we were squaring numbers, a product was 0.04. What number did we take? Square it, and we got 0.04.
0.2.
0.2. Here we have 0.0001. Let me challenge you to find the square root of it. Tell me what is the square root of 0.01. What number did you take, multiply it by itself, and I got 0.0001.
0.01.
0. Wow, I have some brilliant children here, man. 0.01. So we have 2 dp's, and another 2 would give us 4 dp's. Good. Now we have 5.29, and we need the square root of 5.29. And my brilliant students are going to give me that answer.
2.3.
Very good, Neon. We have 2.3. So we found the square root, and these are our outcome. If we square these are what we're going to have. And the same with the numbers that were before. Now we have a fractional number. We want the square root of 1/9. So to get that, we would have had to take a fraction, multiply it by itself, and then we had 1/9. Numerator by numerator, denominator by denominator. Who can tell me what that number was?
1/3.
Wow, 1/3. Very good. So therefore, 4/25 wouldn't be difficult. What would the square root of 4/25 be?
2/5.
2/5. And I bet you can't tell me for 2 7/9. What do you think we should first do to 2 7/9?
Turn it into mixed fraction.
It is mixed here, so we should move it to an improper fraction. So let's do that. So we go 2 9s are 18, and 7 would give us 25/9. And my square root would be
5/3.
5/3. So there we had squares and square roots, and the two of them go hand in hand. Good. Now we found the square root of wholes, then we tried some decimals, mixed, fractional. Now let's try this mixed number. We have 2 7/9. Now before we attempt to find the square root, we change 2 7/9 to a mixed number. 2 9s are 18, and add 7, we have 25. 25/9. And I guess somebody can tell me the answer now, which is 5/3. So if we take a number and we multiply it by itself, we call the product the square of the number. If we take the product and we find the square root, we should have the original number again. And we need to remember that the square root of a number is the positive and the negative of the number. Now, just as how we had table of squares, we also have table of square roots. So we're going to find, first of all, the square root of 1.13. So you're going to turn your sheet again. And on page 256, you're going to have square roots from 1 to 10 there. Now the same thing, we looked at the column 1.0, 1.1, and then we went across 0, 1, 2, 3, 4. So we want 1.13. So we go 1.1, and then we go across and we look for 3, and the two of them would intersect somewhere there. What did you find, Jonathan?
1.06.
1.06. Now you're going to finish off number 2 and number 3. .64, and then we take 7.33. Keisha, what did you find when you found the square root of 1.64?
1.28.
1.28. Miracle? What did you find when you found this, when you looked for the square root of 7.33?
2.71.
2.71. Now our table of square roots ends at 100. If you check it there, 99, and we can find the square root of 100 very easy. However, here we have the square root of 291. Now remember when we were squaring earlier, if we couldn't find it on the table, so we wrote it in standard form. Now we're going to apply the same concept here. We're going to first write 291 in standard form. So 291 in standard form would be 2.91 multiplied by 10 squared. Because remember, this little 2 tells us how many places we must move the point. Good? Now, we're going to find the square root of 2.91, and then we're going to find also the square root of 10 squared, which is 100. .91. So you move down all the way to 2.9, and then you move across the 1. 2.91. Yes, Rennie, what you got?
1.71.
1.71. And what's the square root of 10, Miracle?
10.
What's the square root of 100, Miracle?
10.
10. Thank you. So we multiply by 10. And when we multiply 1.71 by 10, our product would be 171. So we did this together. You will try finding the square root of 375. Could we go ahead and find the square root? What did we have to do?
Because we have change 375 in standard form.
So we wrote 375 in standard form. And what did you write, Neon?
3.75 square
3.75
times 10
times 10
square.
square. Now we find the square root, because this here is 375 we wrote here. Now we apply the square root. So it would be the square root of 3.75 by the square root of 100. Keisha, what is the square root of 3.75? 1.94. And we know the square root of 100 would be 10. So the square root of 375 would be 19.4. So there we have it. We started today with computation, and our aim was to explore square of a number and the square root of numbers. And the square of a number is the number times itself. If we have a positive number or we have a negative number, whenever we multiply the number by itself, the outcome is always positive. Okay? Remember, we can square whole numbers, whether they're positive or negative, decimals, fractionals, mixed. Even if the number is greater than 10, and we're using the table of square numbers, we can apply concepts such as standard form and rounding off and use the tables. Then from square numbers, we move to square roots. And the question we always ask ourselves is, what number did we take, multiply it by itself, and got this product? Now we go the reverse, and we find our number. And the square root of a number is always the positive and the negative of the number. And if you were observant enough, you would have realized that some of the concepts that were applied when we found the square, we also applied them when we found the square root. Now, I know that you had fun today and you enjoyed all that we did. Okay?
Yes.
Now, I want anyone in here to tell me what was their favorite part of this lesson.
My favorite part of this lesson was learning that the square root of any number can be positive and negative.
America, you want to share your view?
And I'd enjoy using the table of square roots.
Was that the first time you encountered the table of squares?
Yes.
Okay, so you have additional knowledge going on today. Good. Now, let us recap what we've done. Now, look here carefully. Lesson 8, Computation, Square and Square Root 1. In this lesson, we will calculate the square and square root of numbers. Here are some key points. When a number is multiplied by itself, the result is called the square of the number. Square root is the inverse of the operation of squaring a number. It's the symbol for square root. Let us look at these numbers and their squares. Number 1 square equals 1 by 1 equals 1. Number 2 equals 2 squared is equal to 2 by 2 equals 4. Number 3 squared is equal to 3 multiplied by 3 equals 9. 5 squared is equal to 5 multiplied by 5 equal to 25. Number 8 squared is equal to 8 multiplied by 8, which is equal to 64. Write one other number and its square. Number 0.1. 0.1 squared equals 0.1 by 0.1 equals 0.01. 3/4 squared is equal to 3/4 multiplied by 3/4 equals 9/6. Number squared, number multiplied by number equal answer. Example 1. Find the squares of A. 0.6, B. 3.42. Solution. A. 0.6 squared is equal to 0.6 multiplied by 0.6 equals 0.36. B. 3.42 squared is equal to 3.42 multiplied by 3.42 equals 11.6964. Example 2. Find the square of 1.5 divided by 0.3. Solution. 1.5 divided by 0.3 square equals to 1.5 multiplied by 1.5. 0.3 multiplied by 0.3 equals 2.25 divided by 0.09, 25. We can use the table of squares to find the square of numbers. Example 3. Use the table of squares to find the square of A 1.1, B 1.25. Look down the extreme left-hand column for 1.1. Then look across under 0. 1.1 square is equal to 1.21. Solution continues. B. Look down the extreme left-hand column for 1.2. Then look across under 5. 1.25 square is equal to 1.56. Example 4. Use the table of squares to find the square of C 1.256. Solution. 1.256 is equal to 1.26. Correct the three significant figures. Look down the extreme left-hand column for 1.2. Then look across under 6. 1.26 squared is equal to 1.59. Example 5. Find the square of 75.6. Solution. Rewrite 75.6 in the standard. 75.6 is equal to 7.56 10 to the first power. 75.6 squared is equal to 7.56 squared multiplied by 10 squared equals 57.2 multiplied by 100 equals 5,720. 7.56 squared equals 57.2 from table of squares. Example 6. Find the square of 156.3. Solution. Rewrite 156.3 in standard form gives us 156.3 is equal to 1.56 multiplied by 10 squared. 156.3 squared is equal to 1.56 squared multiplied by 10 squared multiplied by 10 squared equals 2.43 multiplied by 100 multiplied by 100. 2.43 multiplied by 10,000 is equal to 24,300. From the table of squares, 1.56 squared equals 2.43. Let us look at these numbers and their positive square roots. 0, square root 0. 1, square root 1. 4, square root 2. 9, square root 3. 16, square root 4. Write one other number and its square root. 0.01, square root 0.1. 9/16, square root 3/4. Important point to note. 3 multiplied by 3 equals 9. Negative 3 multiplied by negative 3 is equal to 9. Therefore, square root of 9 is equal to positive 3 or negative 3. Similarly, square root of 36 is equal to positive 6 or negative 6. Square root of 100 is equal to positive 10 or negative 10. Example 7. Find the square root of 9/16. B, 1 and 9/16. Solution. The square root of 9/16 is equal to 3/4. B. The square root of 1 and 9/16 is equal to the square root of 25 over 16 is equal to 5 over 4. We can use the table of square roots to find the square root of numbers. Example 8. Use the table of square roots to find the square root of A, 1.5, B, 1.25, C, 456. Solution. A. Look down the extreme left-hand column for 1.5. Then look across under 0. Square root of 1.5 equals plus or minus 1.22. B. Look down the extreme left-hand column for 1.2. Then look across under 5. Square root of 1.25 equal to plus or minus 1.12. Solution continues. C. C. Our square root table does not have square root of numbers greater than 100. How can we proceed? 450 is equal to 4.56 multiplied by 10. Square root of 456 is equal to square root of 4.56 multiplied by square root of 100. It's equal to 2.14 multiplied by 10 equals positive or negative 21.4. Example 9. The square root of 490 lies between A, 20 and 21, B, 22 and 23, C, 23 and 24, D, 24 and 25. Key. B. Summary. When a number is multiplied by itself, the result is called the square of the number. The square root of a number is that number which, when multiplied by itself, gives the first number. The symbol for square root is problems for today. Page 18, exercise 2K. Questions 4, 8, 12, 16, and 20. Page 19, exercise 2L. Questions 2 and 8. Page 20, exercise 2M. Questions 2, 8, 16, and 24. Mathematics for Secondary Schools in Guyana, Book 3. Solution for the problems given in the last lesson. Page 13, exercise 2F. Round off each of the following correct to the given number of decimal places in brackets. 60. 0.8144 to 2 decimal places equals 0.81. 18. 7.6341 equals 7.634. 22. 0.7701 equals 0.770. 24. 0.0354 equals 0.035. Solution for the problems given in the last lesson continues. Page 14, exercise 2G. Write down the number of significant figures in each of the following: 30, 2, 34, 4, 36, 3. Recap again. Good. Remember now, the square of a number is the number times itself. Whether the number is positive or the number is negative, the outcome is always positive. And squaring of numbers is not only limited to whole numbers. We can take fractional, we can take decimal, we can take them mixed. And remember, we put our hands together, they fold neatly into each other. Now that's the way square and square roots operate. The square root of a number, and you begin to think, now I got 4. What number did I take, multiplied by itself, and I got 4? And what number pops into your mind? 2. And remember, 2 is not only positive, it is also
Negative.
negative. And remember, if you have a large number and you can't find the square or the square root using your sheet, you have the concept of standard form to use. Change up your number, write it in another way, and then you use your table.